In this video, we're going to have a look at Boolean logic. I'm Andrew. In order to understand control flow, the first thing we have to look at is Boolean logic. Control flow statements let us inject decisions in our code, places where we check a condition and then use that condition to adjust what action occurs next in the sequence of instructions that the computer is executing. Sequence is still our foundational element, but control flow will let us select different things to occur next. These are controlled by Boolean logic. So we need to understand a little bit about Boolean logic in order to make use of this. Boolean logic is based around the idea of a Boolean type. A Boolean type is a value that has either a true or a false value. So in this case here, I've got some examples on the screen. Is area larger than 23.5, for example? This would result in a Boolean response. If area is larger than 23.5, if it's 50, then the answer is true, yes. 50 is larger than 23.5. If I had the value 5 in area, then the result would be false. 5 is not larger than 23.5, so the answer would be false. We can use variables. We can use the Boolean type to create variables. We can use them as the results of methods and arguments. So this is a new data type that we can work with. And this data type is essential for control flow statements. The main way we get a Boolean value is usually through some form of comparison. And these are the different comparisons you might apply. So we can check whether two values are equal using two equal signs in C Sharp and C++. Not equal, the exclamation mark equal. Then we have larger than or equal to, and less than or equal to. These different comparisons would let you check, say, the value in a variable with a different variable, or the value in that variable with a constant. You just can compare two different expressions and get from them a Boolean response. You can also combine together these Boolean values using logical operators. This lets you combine together two different expressions into one larger expression. And we can use this to check if both of the things are true. So using and, so we could say, is one thing true and something else true? That's one option. We can use or if we're after one or the other being true. So this would be able to say, is something true or is some other thing true? There's an option to do that exclusively. So this would say, is A true or B true, but not A and B at the same time. It has to be one or the other. And then we have the option to say whether something is not true. Let's have a look at how we can use each of these very quickly. First, let's look at and. So and can be used to check if two values or two expressions are true. The response here, the way we read these tables, is we've got the value of A here, that's one expression, and the value of B here, that's a different expression. And then A could be either true or false, and B can be either true or false. So we can have some expressions here. So A could be, today is Friday, and B could be, it is after midday. And it might look like something like that in the code that we write. All right, so let's have a think. Is today Friday? If today is Friday, then we know that A is true. All right, but we still have to know whether B is after midday or not. If it is after midday, then B is true. And so therefore, the result will be true. That's how we read this table. You look up the value of each of the expressions, and then it tells you the response. For and to be true, both of the components have to be true. So A has to be true and B has to be true. And it should make sense as you sound it out to yourself. So if today is Friday and it is after midday, then it is true. So if today is not Friday, say it's Thursday, then A will be false. And notice then it doesn't really matter what B is, it doesn't matter what the time is, because it's not Friday. Okay, it's not Friday, therefore it's not Friday after midday. Now if it is Friday, so it's true here, but it is not after midday, so say it's 10 o'clock in the morning, then B would be false, and therefore the result would be false as well. So if we know either one of these is false, then we know that the answer is false. We have to have both of them to be true for the response to be true. We can use them for things like this, was the mouse clicked and is the mouse over a button or over something on the screen? Has the user got membership in something and are they in good standing? In these cases, both of these conditions have to be true in order for that condition to be true. Sometimes you want to test if one or another condition is true. Most of the time you'd use an or comparison for that. So we could test, is today Friday, or is it after midday? Or we could test, has the mouse been clicked, or has a key been pressed? So let's have a look at that one. So we could say A is mouse clicked and B is key pressed. So if the mouse has been clicked, so that would mean the mouse clicked is true, then it doesn't really matter whether the key is pressed or not. We know the answer is true because A is true. One of them must be true. They both might be true. That doesn't matter. But we know at least one's true. So therefore the response is true. I don't even have to check whether the key is pressed. And in fact, the computer won't do that where we have what's called short circuit evaluation. It won't check that second part because it knows the first one was true already. So the response must be true. Save some time. Just go ahead. Now, if we know that A is false, so if the user has not clicked the mouse, then we have to check B. So B, if B is false, so if they also have not pressed the key, then the response is false. So it's the only case where we get false, is when they're both false. Now, if they had pressed the key, then the answer of B would be true. So we'd be saying, have they clicked the mouse? No, they haven't clicked the mouse. Okay, I better check. Or have they typed a key? Yes, they have typed a key. Okay, so then that would mean the answer was true. This one here. So that you can use the or logical operator in order to check if either one of these two are true. The third one that we'll look at is not. Not is used to check if something is not true. So what does that mean? We only need one thing here, so is one expression. So A, if A isn't true, then it's not true, makes it false. False, we're checking is A not true? If it's false, yes, it's not true. So therefore the answer is true. So not something, we'll just change it. If it was true, then it's false. Is it not true? Then that would be false. Not false would become true. So it flips the value there. We could use that for something like that. Is it not Friday? So not today is Friday. If it's Thursday, then Thursday is Friday is false. Not false would be true. And that's logically correct, yeah? Thursday is not Friday. So that would be the way we can think about that. We could use it for something like that. Not quit requested. Has the user asked to quit the program? We want to keep doing something while they have not asked to close the program. So we use not for that. And in the code, not quit requested would look something like that. We can also combine these into larger expressions. So here we've got some large expressions combining together multiple Boolean values. So here we've got one where we're checking, has the user got sufficient funds, or, and then in brackets we've got this, whoa, one long expression there. We're checking here is, are they in good standing, and is the cost of the item less than $1,000, and the amount that they owe is less than $500. So if we remember and, that would mean these all have to be true. So we could step this out and do them one at a time. So you could do that and first, and then you could compare these two together to find out those. So if they are in good standing, if that was true, and the cost was less than $1,000, if that was true, then we've got that. So the true and true would give me the result true here. And then I could check over here and say, is the amount owing less than $500? If that is false, then here I would do true and false. And so the result of that would be false. Yeah. If on the other hand, this was true here, this would be the only case, then the response would be true. That would be the only way to get a true response here. So this expression here would give us a true value in the case where, because we've got an or back here, have they got sufficient funds? If that's true, true or, well, it doesn't really matter about this side, would be true. So that would mean whatever is happening could go ahead. So the result of this would be true. If this is false, then we have to check this side, and all of those three things would have to be true in order for this to continue for whatever this is controlling. We could change it around by changing the position of the brackets. So here we can say, have they got sufficient funds, or are they in good standing? And so that would all have to be true. Yeah, and we can then combine that together with and. So the cost of the item less than $1,000 and the amount owing less than $500. So these ones here would always have to be true for this to be true because we've got these ands here making them a requirement. Whereas here they could either have sufficient funds, so maybe they don't have sufficient funds, but they are in good standing. So if they don't have sufficient funds, they are in good standing. False or true is true, and the cost is less than 1,000, so that's true. And the amount is less than 500, and that's true. So it'd be true, and true would be true. So often you don't have to think through the specifics of this. Usually you're thinking about what you're wanting to achieve. So you think about what you want to achieve. I want to achieve this effect. What is the conditions that I need for that to happen? So that might be, I need the mouse to have been clicked, and I need the position of the mouse to be above the item on the screen. And so then you would be using ands. Or you could be saying they either could have clicked this button or they could have typed this key. So maybe, has the button been clicked and the mouse is over the button, or is the user holding down the control key and they're holding down the S key? So that would mean control S or clicking the button would perform the same action. These are the operators used in C-style languages. So and is 2 ampersands, or is the pipe, 2 pipe symbols, XOR is the caret there, and not is the exclamation. So these are examples of how to represent this in your code. Here's an example of using these kinds of expressions in code. So we've got an if here, where we're checking the condition, does the language equal C#? Here we've got an or, so we're saying, is the language equal to C#, or is the language equal to C++? And these are the sort of ways that you would see these Boolean expressions appearing in your code. And we'll look at these in a little bit more detail very soon.